This video demonstrates the operation of a break, make, push button. The button is constructed with a set of normally closed and normally open contacts. When the button is not pressed, the normally closed contact completes the circuit to the red pilot light, switching it on. At the same time, the normally open contact opens the circuit path to the green pilot light, so it remains off. When the push button is pressed, the normally closed contact opens to open the circuit to the red pilot light, switching it off. At the same time, the normally open contact closes to complete the circuit path to the green pilot light, switching it on. This video demonstrates the operation of an emergency stop push button. Emergency stop push buttons are maintained contact types with mushroom type heads. Unlike momentary stop push buttons, emergency stop types are designed to prevent a motor control process from restarting until the maintained push button is physically reset. The normal motor start-stop push button operations apply. With the motor running, pressing the emergency stop button opens its normally closed maintained contact. The motor stops and start-stop process remain inoperative. To restart the motor after the emergency stop push button has been activated, you must first reset the emergency stop push button and then press the start button. This video demonstrates the operation of an emergency stop push button which combines its operation with two motors and pilot lights. The normal operation of motors M1 and M2 are individually controlled by their associated start and stop buttons, PBS1 and PBS2. When illuminated, red pilot light M1 indicates that motor M1 is operating. When illuminated, green pilot light M2 indicates that motor M2 is operating. If the emergency stop button is activated, both motors will be de-energized regardless of their current state. Once the emergency stop button is activated, it must be manually reset in order to commence normal operation. This video demonstrates the operation of a remote run pilot light. Pilot lights provide visual indication of the status for many motor-controlled processes, permitting personnel at remote locations to observe the current state of the operation. In this scenario, the red pilot light is used to indicate whether or not the motor is operating. The pilot light is connected in parallel with the M starter coil. It is assumed that whenever the starter coil is energized, the motor will be operating. This video demonstrates the operation of both standby and run pilot lights. In this scenario, the green standby pilot light is used to indicate that power has been applied to the motor control circuit, but the motor is not in operation. The normally closed M contact is connected in series with the green standby pilot light to complete the circuit and turn the green light on anytime the circuit is energized, but the starter coil M is not. The red pilot light is connected in parallel with the M starter coil and turned on at any time starter coil M is energized. When the circuit is operated from standby to run, the normally closed M contact opens to turn off the standby green light, and the normally open M contact closes to switch on the run red pilot light. This video demonstrates the operation of a push-to-test pilot light. Push-to-test pilot lights are designed to reduce the time required to troubleshoot a suspected faulty lamp. This pilot light is energized from any one of its two inputs, normal or test. The test terminal input is connected directly to the opposite line side of the circuit. Pressing the push-to-test pilot light opens the normal signal input to the light, while at the same time completing a path directly to L1 and illuminating the lamp if the bulb is not at fault. This video demonstrates the operation of a 3-position selector switch circuit. Selector switch operator is rotated instead of pushed to open and close contacts of the attached contact block. Switch positions are established by turning the operator knob right or left. In this scenario, the 3-position selector switch used to select 3 different operating modes of operation: off, manual, and automatic, for control of a pump motor. In the off position, the manual on-off switch or the float switch have no effect on the operation of the circuit. In the manual on-off position, the pump can be started by closing the manual switch and stopped by opening the manual switch or selecting the off position of the selector switch. When automatic is selected, the float switch controls the pump. At a predetermined level, the switch will close, starting the pump. At another predetermined level, the switch will open, stopping the pump. This video demonstrates the operation of a limit switch. Mechanically operated limit switches are designed to operate only when a predetermined limit is reached. They are actuated by contact with an object, such as a cam. Mechanically activating the limit switch causes the contacts and corresponding pilot lights to change states. This video demonstrates the operation of limit switches, providing overtravel protection. Activating the momentary forward push button completes the circuit for the forward coil. Closing the normally open maintaining contact and sealing in the circuit for the forward starter coil. At the same instant, the normally closed interlock contact F opens to prevent the reverse contacts from closing. To reverse the motor direction, the operator must first activate the stop button to de-energize the forward coil, and then activate the reverse push button. If the overtravel position should be reached in either the forward or reverse direction, the respective normally closed limit switch will open to prevent any further travel in that direction. The forward direction is also interlocked with a normally closed R contact to prevent the forward contacts from closing when the motor is running in reverse. This video demonstrates the operation of a temperature switch utilized as part of a motor control circuit. A temperature switch rated to carry the full load motor current of the fractional horsepower fan motor is used. A double pole manual starter is used as both line leads for the 140 volt single phase source must be switched. When the 3-position selector switch is in the auto position, the temperature switch reacts to a preset rising temperature to automatically switch the motor on. When the temperature drops below the preset value, the contacts open to turn the motor off. This video demonstrates the operation of a float switch control of alternating pumps for removing fluid from a tank. This type of control is used when a pumping operation is frequent. Too much stress may be subjected to a single pump motor. In such cases, 2 pump motors are designed to operate alternatively. The float switch is a normally open type. At initiation with the tank empty, starter coils M1 and M2 as well as the control relay coil CR are de-energized. When the fluid in the tank reaches the full level, the float switch contacts close to energize starter coil M1 and start pump motor 1. M1 auxiliary contacts then change state to energize control coil CR. When the fluid reaches the empty level, the float switch contacts return to their normally open state. This de-energizes starter coil M1 to halt the pumping operation. At the same time, control relay CR remains energized through its seal-in circuit. When the fluid in the tank reaches the full level for the second time, the float switch contacts close to energize starter coil M2 through the CR contact and start pump motor 2. When the fluid reaches the empty level, the float switch contacts return to their normally open state to de-energize starter coil M2 and halt the pumping operation. The sequence is reset by each activation and deactivation of the float switch. Pilot lights provide visual indication of the status of the process. This video demonstrates the operation of a relay motor control circuit. The relay enables the motor high-power line circuit to be switched by a low-power 2-wire proximity switch. In this scenario, the proximity switch operates a relay coil whose contacts operate motor starter coil M. With the switch on, anytime the proximity switch contacts close, relay coil CR will become energized. This in turn will cause the normally open CR contacts to close and complete the path of current to the M motor starter. The M motor starter energizes and closes the M contacts in the power circuit, starting the motor. When the proximity switch opens, the CR coil de-energizes, opening the CR contacts, which in turn de-energizes coil M and opens the M contacts in the power circuit to stop the motor. This video demonstrates the operation of a solenoid-operated tank filling and emptying process. Assuming the liquid level of the tank is below the full level mark, momentarily pressing the fill push button will energize control relay 1CR. Contacts 1CR1 and 1CR2 will both close to seal in the 1CR coil and energize normally closed solenoid valve A to start filling the tank. As the tank fills, the normally open empty level sensor switch closes. When the liquid reaches the full level, the normally closed full level sensor switch opens to open the circuit to the 1CR relay coil and switch solenoid valve A to its de-energized closed state. Anytime the liquid level of the tank is above the empty level mark, momentarily pressing the empty push button will energize control relay 2CR. Contacts 2CR1 and 2CR2 will both close to seal in the 2CR coil and energize normally closed solenoid valve B to start emptying the tank. When the liquid reaches the empty level, the normally open empty level sensor switch opens to open the circuit to the 2CR relay coil and switch solenoid valve B to its de-energized closed state. The stop button may be pressed at any time to halt the process.